Live.
But remember to look at this one, not that one.
Hey guys, welcome back to the Science Kid. So this is the very first trial day of the TheScienceKid Camp, and we are starting now. It's the 3 states of matter. Yes, 3 states of matter. You've heard it. Okay, just waiting for people to come in. Dun 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 dun. Okay, no copyrighted music. No copyrighted music. Okay. Someone says they're in. Who is watching? Darian! You're watching.
Hello.
People are here! Woo! Hello. Okay, we're gonna wait for at least like 5 people to come in or something like that. Around 5. And we'll get started because it's the trial day. I got a ton of stuff prepared. Okay. Just do something here. Right. Okay, so just by the way, there may or may not be some technical difficulties since today is the very first day. And as you can see, I am not super prepared, but I am doing my best. 5 people! Dang! Okay, I want everybody to comment and say hi, okay? Oh, and by the way, if you guys say anything in the chat, if I don't see it, then my brother Truman's over here, and he's the person with that hand, and he's gonna tell us stuff. Woo! No, someone left. Should I wait? Okay. We're gonna go ahead and get started. Alrighty. So basically, as you may or may not know, we are doing the 3 states of matter. Now, the 3 states of matter is not super complicated. So I have my nifty little paper here because I haven't memorized anything. So pretty much with the gases, so with the 3 states of matter, there's gas, liquids, and solids. Now, with the gas, liquids, and solids, they all are a little bit different. Now, the universal way to show anything, like any state of matter, is water, basically. Hello, people. Hello, chat. I'm just going to call this chat for right now. Everybody in the chat. Okay, cool beans. So pretty much, water is the universal thing for gas, liquid, and solids. So for gases, you have, the meaning is about like a state of matter without a set shape or a volume, which is like pretty much saying like a gas cannot be in a certain, I don't know, you can't really form a gas. Like you can, like for example, like I have water here. Now, liquid is a state of matter with a set volume and shape. So, like for example, when I poured the water in here and turned it blue, it is in the shape of this thing. So, pretty much it can change shape and form. Now, with solids, like for example, this bowl, right? We have this bowl here. It is the state of matter with a set volume and a set shape. So, that's pretty much how it works. All right, so now I got us some experiments to do for today. So pretty much, the first thing that we have going is we have an experiment on making a solid. So we're going to turn a liquid to a solid. Well, not necessarily, but it's like, let me put this way. So when you have a gas, solid, and a liquid, it's going to be like, let's say that water is like a person walking at a normal speed. And so pretty much there's energy inside of someone walking, right? So when they're walking from one side of the room to another, they have energy in themselves. So when the energy is just about normal and you're about walking. Now, what happens when you take a object or a person that is just walking and you speed them up? Basically what happens is the person starts running, right? So pretty much when you take a liquid and turn it into a gas, it basically goes from a person walking to running. Now, what is kind of interesting is that there's a way that we can do that. So what I'm going to do is take this nifty little thing, tea kettle, and this is going to be the experiment. So I'm going to take the lid off, right? And I'm going to pour some water in there. Okay, the water is in. And I'm going to put the lid on so heat doesn't escape, and I'm going to turn it on. So basically the way that the tea kettle is working, you're taking like electric charges and it's working to make heat, which I find is kind of interesting. Okay, so pretty much when you have this, well, while I have this going, I'm going to explain some stuff, and this might get a little bit loud. So anyway, when you have solids, like from let's say like how the person is walking, when they go to a solid, they go really, really slow. It goes from, a walk and a trot to like that, almost not moving at all. So pretty much saying the energy inside of the water gets slowed down immensely. So that's basically what makes it have a set shape and a form. Now, what I find is very, very, very interesting is in this kind of stuff, like what's going on here, is that the water is turning into something else. So let's see. It's not exactly done yet, but it's getting going. So if anybody has any questions, just go ahead and put it in the chat, and I will be all good to answer them. Yes. Okay, so, all right, let's see if we can get this working. Okay, so pretty much as I was saying, there's water, right? Or any liquid, it could be literally any liquid, like, I don't know, whatever you want to call this is like basically the color of Gatorade anyway. You have this liquid, and it can turn solid or a gas. And, okay, I'd say this is about done. Okay, are you ready to see what happened? It's going to be amazing. In 3, 2, 1. Whoa! See all that steam? There's steam right here. So basically, steam is the gaseous form of water. Now, it's actually kind of cool, even though you do it every day when you make coffee or tea or whatever hot liquid you're making. But you're doing a very interesting experiment where the energy inside of the water is being like going supercharged. It's just like that. It's insane. Okay, so the next thing that we're going to do is we are going to make basically a solid. So the easiest way for me to do this is I have a bowl. It's got nothing in it yet. But pretty much what I'm going to do is I'm going to take the hot water from inside of the kettle and I'm going to pour it inside the bowl. Whoa. See all that steam? You might be able to not. Steam coming from inside that. Okay, so pretty much what we're going to do to show that it's like actually hot liquid, I have this measuring tool here that measures how hot stuff is, so I'm going to stick that in there. Oh, there we go. It's going up. Let's see what it gets to. Okay, so it has stopped. It is at approximately, I don't know if you can see it really well, but it's at about 160 degrees Fahrenheit. which is about the temperature of boiling water. So that's actually pretty cool. And so when you have like the hot, like really hot water, it's interesting. And it's actually at that temperature. Now what we're going to do is we have our thing that is going to make it very cold very, very fast, which is ice. In this. So I'm going to pour this in here. Slowly but surely it shall come out. You know what? I'm going to use safety so this doesn't splash into my eyes. Yes, safety first. And the ice is already shrinking. So the ice is our solid form of water, which is like really slow, and I'll show you in my hand. And something actually really interesting is when you take a thermometer and you scan your forehead or whatever, it will show up at about 98.6 degrees Fahrenheit, which is the which is your body temperature. So when you take a piece of ice, like I will soon have in my hand, if this wants to come out, oh, there we go. We got one. It's like a fish. Okay, so if you hold one in your hand, it's going to start melting and go back to its water state. Oh, there we go. They're all coming out now. Okay, all of the ice is officially out. So, basically saying, you can see the ice cube is now getting a little bit smaller. And now my hand is very cold. Oh gosh. And the ice cube is shrinking. And it's because, our bodies are about 100 degrees Fahrenheit, which is fairly hot. Now, before, I would not want to touch this water. But before I do, I'm going to use the handy dandy, I guess this is a meat thermometer, but it goes all the way up to 190 degrees Fahrenheit. So if it doesn't, let's see. Yep. Now it is cold, and I may now touch it. Oh. Yeah, so now it's not reaching any of the numbers, which means it has been cold. Now, basically saying when I do this experiment, it's that the solid objects, when going with something that's warmer, it's basically making the energy, boot up again. It's like eating a candy bar or something, and it's giving your body a whole ton of energy, which is pretty cool. Okay, so next experiment. So we're going to do this one a couple times, and I'm going to move this stuff out of the way. So this one is going to be using something fairly handy. This is called, well, I'm just going to take this whole thing out, Alka-Seltzer. Woo! Interesting stuff. So when you take Alka-Seltzer, and normally when you put it in water, it does something that's kind of interesting. So I'm going to take it, just one of these, and I'm going to do this, and I'm going to put water in here. Okay, and you don't really need that much water for this. So as you see, if I drop this in here, wait, hold on, quick, somebody type in the comments what you think is going to happen when you put Alka-Seltzer. It's kind of in its name what happens, big hint. Okay, I'm going to put it in. 3, 2, 1, go! It's starting to fizz up a lot. There's a lot of fizzing up going on there. Now, basically how this works is, it's basically, I don't know how to explain it, but it's like carbonized, and it comes up and it starts sparkling like crazy. Like an insane amount of this. So, basically, when this happens, there is being a gas that is released. Now, I can use this to, I don't know, I can use it to make something explode. So, yes, that's right, you're going to see some explosions. I mean, it's not like fiery explosion, but it's an explosion. So, when you're doing this experiment, you're probably going to want to use some blah, can't talk anymore. Some kind of safety equipment. And I got me some goggles. Okay, I got some safety equipment right here. And so this is what we're launching. This peculiarly small little thing. And so once again, I'm going to be using some of this interesting thing called Alka-Seltzer. Oh gosh, I don't know where that one went. So when you're doing a small thing like this, I'm just going to give you guys some helps and tips. You only want to use a really small amount, and most of the time you only want to fill it up about 3/4 of the way full. No, it's more like, no, 1/4 of the way full. Yeah. And so that way you give it enough room for the gas to come up, and so it. All right, so I'm just gonna use a little bit of purple liquid. I'm just calling it purple liquid today. All right, there we go. We got. That's a little too much. Yeah, I'd say that's about it. Now, you want to use a fairly small amount of Alka-Seltzer, and you're going to put it in, and I'm going to put it on top of this glass so you guys can see it explode a little better, like this. So basically what you want to do is I'm going to put this inside of the little cap I have here. So when I put it on, it's able to go here. Oh, yes, 100,000 subscribers at a video challenge. Absolutely, drop a like. Yes. Okay, so I'm going to put this in. You guys ready? 3, 2, 1, go. Okay, it's starting to fizz a little bit. Safety equipment. That's basically how it works. And you can actually do it multiple times with the same little bit of Alka-Seltzer. And if I continue to put it in, and if you get it just right, like again, the gas will expand. I'm just going to back up a little bit here. See if it goes again. Is it going? I guess not. Okay, it's not going. There's still gas in here though. Listen. Oh, there we go. This is our mini version. Now we have big version. Now I'm just going to have the cork fly for this one, and I'm going to move this glass out of the way. So I'm going to take, once again, our purple liquid and only fill it up about 1/4 of the way through. Now for this one, the more liquid you have, I'd say the more, like the more space you have and the more liquid you have, the bigger explosion you're going to have. That's the best way to put it. Kablooey, exactly. So I'm going to put this on here. And I'm going to grab another packet of Alka-Seltzer. By the way, if you want to get Alka-Seltzer, they sell it at like a lot of stores. And they normally come in big amounts. Oh gosh, my hands are wet. I can't do it anymore. Oh, there we go. Got it. Oh, all right. If you want the reaction to happen faster, which is like the easiest thing, so it goes kablooey, like a lot faster. The easiest thing to do is to break it into, oh gosh, very tiny pieces. All right, this one's still too big. All right, now, when you have a big one like this, I have a funnel. There we go. Oh, this one's still too big too. Man, there's a lot of me breaking up some. Me breaking up these bits and pieces of Alka-Seltzer. All right. Here we go. Okay. You guys ready? Now, hold on. I gotta make sure, because like when you have a kind of beaker like this, you want to make sure there's some resistance from when you pull it off. Like for example, when I do it, makes a loud noise. Oh, there we go. There's the noise I'm looking for. Okay. Now I don't even need the cup. All right. Now the gas, as you can see, is filling up, and it is going to rise fast. And it takes a second. It's not immediate because the gas still has to pour. Okay, I really don't want to get hit by this. Looks like it's turning blue on top. Interesting. All right. I can hear it. Hopefully there's no gas escaping. Why did I take my goggles off? That was not why. Someone in the chat should have told me not to take my goggles off. Jeez. There's no gas escaping. Interesting. Let's see. It's gonna go soon. Trust me. Last time I did this, I went to touch it, and as soon as I went and touched it, it went. It exploded. So now I don't wanna touch it. Come on! I want to go like abracadabra. Because if I have to take the cork off, I'm going to be sad when I hear a ton of hissing sounds because it has already gone off. Okay, yeah, I don't think it's gonna go. So, just one thing. Oh gosh, okay, that wasn't too loud. I'm going to dump this into the excess bowl. So, if you don't get it to work with the Alka-Seltzer, just one thing that works really well is if you take vinegar into it, because the vinegar makes the Alka-Seltzer go really fast. So, I don't think I even really need the funnel. Well, at least for, putting in the Alka-Seltzer. All right, let's get this one in. All right, it's about a quarter. Now, since that didn't work, I'm going to put in 2. Let's see if that works. Okay, so this time it actually might be fairly large. So, sorry in advance, Truman, if it hits you. All right. Now, basically, I haven't explained this yet, but when this is happening, it's like it's a solid turning into a gas, and the gas like builds up and it goes. You can already hear it starting to go. No, it's not going in. It's going a lot faster this time. Oh my god. Well, that's not good. I put in way too much Alka-Seltzer. That would have gone really high up in here. Okay, I think I can still salvage it. Okay, I definitely had the cork on the wrong way last time. That's what the issue was. It worked. Aha. I told you it would work. And vinegar really works a lot faster. That was kind of messy. Interesting. Okay, if I get 2 people in the comments to say do it again, I'll do it again. If I can get 2 people in the comments to say do it again, I'll do it again. Oh gosh, that's loud. That's some loud stuff. Oh, I only had to use 1 packet last time. Okay, well, with vinegar, you don't need that much. Wait, no, I put in 3. That's what the issue was. Okay, so we're gonna try another thing. I'm gonna put this in, and wait, hold on. 2 people haven't said to do it again. Am I getting 2 in the comments? I'm waiting. We'll move on. Lava 5000, is that a vote for another one? Huh? Okay, we got 1 vote. Are we gonna get 1 more? I like this experiment. What else do I have? What do you mean, what else do I have? I have tons of experiments. Just around the corner. Okay, we got more than 2. We're doing it again. All right, that's actually probably a better amount as I pour more in. Okay. Vinegar is heavy. Okay, so now we're going to try it with only 2. I just realized I have no clue where my cork went. Okay, well. It absolutely disappeared. Oh, okay. Right underneath the table. I want to get a slow-mo of that happening. Oh my gosh, you're right. We are at a record of 8 viewers. 100,000. 100,000? Okay, well. Interesting. Okay, that's not too big, hopefully. Okay, I'm going to check before I do it to make sure I have the right side in, because that's why it did not work the first time, like at all. Okay, I think it's the side that's probably wet. I'm just gonna try both sides again. Okay, that was a lot harder to put in. Oh no, that one's it. Okay, the one that's dry. Gotta remember that. You know what? I'm not gonna use all these because I don't want it to overflow. Ah! No. With vinegar, it happens way. That was loud. Oh gosh. Okay, so next thing we're going to do. So when you have this going on, now I don't know if you guys know about this, and it's going to be in our next experiment too. When you do when you put 2 ingredients together, that's an acid and a base, it creates like a bubble solution. Anybody in the comments know what those 2 items are? Anybody know? Truman, you better not say anything. Okay, I'm just gonna pour this stuff up here. It's vinegar and something else. Yeah, I know. We're doing it again. But again. No, come on. All right, I'm gonna put a couple towels down because I don't want it going everywhere. All right. Now this is why it's the trial day. Not everything is completely prepared. Just keep in mind, the stream might just drop. It might drop. You never know. Oh, 9 viewers. New record once again. We're breaking the record every new. Oh gosh. Oh well. Okay. So anybody want to know what that? Okay, I'm just gonna tell you guys what the ingredients are. The ingredients are, like I said, vinegar and baking soda. Woo! Amazing stuff. It's about to get crazy with the vinegar. So what I'm gonna do is I'm gonna put the baking soda and the Alka-Seltzer in first, so that when the vinegar goes in, it starts going, because it's not good if you put in the stuff at the same time and then you add it. It's like when cooking, you always want to do the dry and wet stuff separately. Now I might start getting a little bit of a reaction because I still have some vinegar left in there. But it should be okay. And when you're doing this, you don't need to put in that much baking soda. Because basically all that's going to happen is it's going to be louder and it's going to go up even faster than before, which just sounds insane because it happened fairly fast last time anyway. I just realized there's going to be a reaction that's going to happen inside of my funnel here because I've got some Alka-Seltzer and this funnel is not so close. Oh wait, let's just use this to push it down. Okay, there we go. So I might get a little bit of a reaction inside of here already. Now when you do this, just put about, I don't know, not a ton of vinegar. Not a ton. Ugh. Okay. You know what? Wait, I have to find a cork again. Oh, it's right here. Okay. You know what? I'm just gonna move stuff out of the way because I don't want my glass stuff breaking. Wait, it's the dry side, right? Yes, it's the dry side. I'm gonna keep it like this. Okay. No. Okay, it's already releasing a lot of gas. Oh no, I think the gas is escaping. Oh dang, I thought that was did anybody catch that? I think it went inside of the funnel. Like, interesting stuff. Okay. Unless anybody wants to see it again, I want to move on to the next experiment. I didn't just do that. You witnessed nothing. I probably could have just left it in here. I'm not using this one. I got all sorts of reactions happening. Oh, and extra points to anyone who knows what kind of reaction it is when baking soda and vinegar mix. Gotta move everything. Okay, now for this, this is going to be our kind of most interesting thing. So the ingredients you're going to need is water bottle, any sort of used plastic bottle. I mean, I probably could do it in this, but I don't want it to like break or anything. Okay, and then you're going to need some more baking soda, some more vinegar. Oh, why is this so heavy? Jeez. And you're going to need some balloons. That's right. We're using Kaz 1,100,000 subscribers without videos challenge. Congrats, acid-base reaction. I'll give it to you. Okay. So the first thing you want to do with like this, because otherwise I've done this before, and I even put Alka-Seltzer in that, and I'm going to try doing that again. It was mayhem, literal mayhem, because when you do it, and if you don't blow this up, the bottom of it expands and not the top of the balloon, and so this gets really wide, and then it just, and it comes off. So you want to make sure you blow into the balloon first, like this. I can't blow up a balloon. Wait, you know what? I'll do this first. Because, like I said, if no air can get into, like, this part of the balloon, and I feel like I can't even get in, it's like, it's a really tough balloon. Pause in the chat. I blew up a balloon. Best sound on earth. Okay, so pretty much what I was saying is you want to take all the dry stuff and wet stuff and you want to put it on different sides of the experiment so you don't, get anything weird. Okay, let's see. So I'm just going to use this because it's kind of hard to pour baking soda into a balloon. So the easiest thing to do is once again use my trusty funnel, but it's not super trusty because it's not letting me put the balloon over it. Ah! I don't know why I'm having so much trouble doing this stuff. Okay. Aha. See, you guys, I still got it. I got a balloon on a funnel. Isn't that crazy? Okay, got the. I just. Oh gosh. Well, now I know how to do it correctly. If anybody has, oh yes, that's right. So if anybody has any questions. Oh my gosh. Why am I having so many issues with this? I don't want to pull this off, but I'll make sure it's centered. Okay, we've got the balloon on here. And you want to pour a bunch of baking soda in here. Oh gosh. And you want to get it down into the center of the balloon. And, oh gosh. And basically saying with the baking soda and vinegar reaction, the more baking soda and more vinegar you put in, the bigger the reaction is going to be. Oh, I just realized I prepared you guys for the worst. I told you there would be technical difficulties. And there was just some, well, that was a technical difficulty? What do we call that? Well, with the magic of editing, it never happened. That's right. Editing's wonderful. You know what? It's got enough vinegar in it. It's got enough baking soda in it. Okay, and the next thing we're gonna do, I'm just gonna. Everything already has vinegar in it. Why is this? Okay, so what we're gonna do is we're gonna pour some vinegar inside of the water bottle. And if anybody knows how this experiment's gonna end, just go ahead and put it in the chat. I'd like to know, because I definitely haven't done this before. Okay, now there's another way you could do this, like preparing for the experiment. You could just put the two inside, and if you're a fast balloon putter on or water bottler, I don't know what that word is. I'm just great stuff. Okay, and you can put it on fast. You could just put the two in, and then. Man, I'm having trouble with balloons today. Jeez. All right, now I'm gonna try to get this on here. First try. Oh my goodness, just too good. Okay, now with this experiment, observe what happens. So we got vinegar, baking soda in a balloon. What is going to happen? Let's find out. Oh my goodness, it is magic. Oh gosh. And the good thing about this is it won't. So basically how this experiment works is we have a solid and a liquid, and it mixes together, and it creates a gas up on top. It goes. Now, does anybody know what kind of gas is being released from this experiment? Anybody know what kind of gas this is? Nobody look it up. I don't want cheaters. Okay. So basically, it blows up the balloon. But if you think about it, it's pretty cool. And it's not bad of an experiment. Okay, so anyway, we got a balloon here. So basically saying, I'm just going to tell you guys what kind of gas it is. It is carbon dioxide, the stuff that you breathe out. There we go. I wonder if there's a delay where I see it or something like that. No, but it is not helium. That would be cool though. The only reason it's staying in place, otherwise it would be, like this if it still had, when you do it and you put too much of the baking soda in, it'll go like that. And that's one of the ways that only this part would blow up, and it goes like that. And so I'm just going to go like this. That's enough. Anyway, so this is carbon dioxide. So I'm just going to,
Give it to the plant.
Yeah, so basically saying when you do this experiment, you have a dying plant, give it to the plant. I probably should go give this to my plant. You go give this to the plant. I'm giving this to a plant. Okay, so anyway, I'm going to do this experiment again, but you guessed it, Alka-Seltzer. Booyah. Oh gosh, my hands are all wet. It's probably good that I put down a towel. Okay. Oh, well that was the balloon. Oh yeah, I gotta blow it up again. Okay. So we already have vinegar in here, but a majority of the time when you do it, you don't want to have the same vinegar in there because you've already used it. Oh, okay. So once again, we got this thing, and we got this thing, and I gotta put this on this. This is just interact with the chat more. I am. I'm asking for questions. I'm asking for questions. Any random science questions, I will most likely have the answer to. Okay. Yeah, so I need this. I don't know why, but this thing doesn't like going in. Oh, there we go. Whenever I say it doesn't work, it works. Every time. Every time. And you don't want to put too much of the baking soda in there because you want to save room for the Alka-Seltzer. And when you do it, you kind of want to just do a little bit less of the baking soda, and then you only want to use one of these. And also, it's pokey, so you want to make sure it's small and don't make it really sharp because then it'll puncture the balloon. And then whole experiment's no go. Okay, got this in there. Got one of those. I know this must be very interesting, watching me break apart Alka-Seltzer. Okay, I'm gonna have this in here. I almost thought there was gonna be a reaction inside of them. Wait, I actually want to try that now. That'd be interesting. If anybody wants to see me put vinegar and baking soda inside of a balloon, just by itself, tell me. Okay. I also forgot to put vinegar in. You guys are just watching the best of the Science Kid right now. Kind of wonder if I put too much stuff in and then it will just pop off. Okay. Okay. Gotta move this over a little bit. And also you want to make sure, did some of it already get in? It's already starting to blow up a little bit. Okay, so I'm gonna pour in 3, 2, 1, go. Now this one, it still makes the carbon dioxide. But as you can see, it blows up a lot faster. Well, it started blowing up a lot faster. I don't think it's making as much carbon dioxide. Interesting! This is why we do experiments, people. Okay, well, that's what happens when you put Alka-Seltzer in it. It's not as cool. Okay, so I'm going to take this off again. It didn't spill over. Well, that was nice. I got a whole bunch of carbon dioxide. You know, I don't think the balloons like me today. I just don't. All right. Okay. Why can't I blow up balloons? I can't blow balloons. I can't blow up balloons. Why? Why is this? Why is it so hard to... What am I doing wrong? There we go. Okay, so should I put both baking soda and the Alka-Seltzer in there, or just Alka-Seltzer and vinegar? Questions to be answered. Okay. Once again, going to put down. Oh my gosh. No! Okay, here we go. First try. I feel like I got a cut on my hand. I didn't know. Interesting. Okay, so I'm gonna put the baking soda in. Wait, water in there too? Okay, so we got this in there. Oh, it looks like the camera got moved to the side a little bit. Oh, okay, there we go. All right. And, all right. Should I put the cork on the balloon? Okay. Let's see this. We're gonna do a little bit. I don't think it's making any gas. Wait. No, it's not. Very little. If I do this, it bulges a little bit. Let's see. Now, what would happen if I put... I'm going to take some Alka-Seltzer, and since it's already wet, I'm going to take this, put it there, take this, put it in here, okay. All right. Now I'm just going to put in a little bit of water. Maybe I should put a clip on. Oh, there we go. Some gas is starting to happen. Ah. Oh gosh. It's starting slow, so it does work. I wonder if you could put like do this with a mister, like do some like sort of tablet, but it could be like a misting thing. So it is making stuff. Hello, the Michael Man. Hello there. So this is heavy. Okay, hold on. I'm gonna just. Okay, so that did almost nothing. Now if anybody wants to see any of the experiments one more time, let me know. Because that was all the experiments. Okay, I'm just squirting out everything from this bowl full of stuff. Okay, so basically saying, since this whole thing has to do with 3 states of matter, basically saying it is the gas and the liquids and the solids, and like with those 2 things, it's the solid and the liquid mixing together, and then it makes a gas because it is an acid-base reaction, and when it goes together, it like fizzes up and it creates carbon dioxide. Just remember that. Someone will ask you that later. Might be me, maybe later in one of the later golf games. You never know. Oh gosh. Okay. Last time to ask any questions because we are almost done. Anybody want to ask any sort of questions regarding science? Pretty much anything. Really doesn't matter. Last chance. You sure? Okay, well anyway, I'm just gonna plugging myself is not bad. Anyway, so what I'm going to say is that I posted a video yesterday on the science behind fireworks, so if you want to see that, there should be, why do I have a tea kettle here? Because I was warming up water, that's what I was doing. I was making, I don't know why I snapped my fingers. I was making a gas, which is the gas, like steam, which is the gaseous form of water. And basically saying I posted a video about fireworks, and you should go watch that. And if you're new here, make sure to subscribe. Also, I'm going to continue doing more of these science camps if they go pretty good. And, well, most likely I'm going to do them anyway. And they're probably going to be more coordinated than this because this is just the trial run to see how like live stuff works. Because I haven't done any live stuff before. This is the very first time, so that's why it's going a little wonky. Okay. No questions? No questions? No questions? All right. I'll make sure to see you guys next time. Bye-bye.